Welcome back to Algebra 2. I hope everybody is safe and sound in their homes. Hope you had a nice little break. We're going to get ourselves started in Chapter 10 today with Section 1. And what we're going to be looking at today, guys, is we're going to start looking at a concept that sounds awfully easy. We're going to start looking at a concept called counting. Obviously, pretty self-explanatory. What we're going to be doing is counting the number of ways in which different things can occur. Sounds like it's going to be something very, very simple, but actually turns out to be a more complicated problem than you can imagine most of the time. So we're going to get started with a real easy problem. We're just going to take a couple of folks from our class. So maybe we'll take, maybe we'll take someone called Abby. And we'll take someone called Ben. And what we're going to do is we're going to count the number of ways in which they could stand in a line. Let's say that we're going to a program in the auditorium and we're going to line up at the door. All right? In how many different ways could Abby and Ben line up at the door? Well, it's pretty easy, right? Either Abby could be first, I'll just use capital A to represent Abby, or if Abby is first, then Ben has to be second, so that would be one option. Or a second option, Ben could be first and Abby could be second. So for two people, I think the obvious answer is there's two ways in which they could stand in a line. But what if we were to add a third person? Now with Abby and Ben, we also included Chuck. Now, how many ways could three people stand in a line at the door? Well, Abby again could be first, Ben could be second, Chuck could be third, or if Abby remains first, Chuck could be second, and Ben could be third. Or, well, if Abby's not first, maybe Ben is first. And if Ben is first, then Chuck could be second, and Abby third. Or, if Ben is first, Abby could be second, and Chuck could be third. But who else could be in that first position? Exactly. Chuck could also be in the first position. And if Chuck is in the first position, Abby could be second and Ben third, or Ben in the second position and Abby third. So there would be a total of 6 ways in which we could, align or stand in a line for those 3 folks. Okay? Now what we'd like to do is extend again to another person. So extend to Abby, Ben, Chuck, and now Danny. All right? And we could start trying to list out all of the different ways in which they could stand in a line. All right? And once you start to get the hang of it, it's not so bad. But we could start positioning Abby, Ben, Chuck, Danny. If we left Abby in that first position, Ben in the second position, we could switch Chuck and Danny, and we could continue that process of trying to find all the different ways in which those 4 folks could stand in a line. All right? I know we're not all together, but can anyone take a guess as to how many total ways that could happen? Yeah, it actually ends up being 24. 24 different ways in which 4 people could stand in a line. Now, if we were all together in Algebra 2 like we normally would be, we'd have a total of 27 people in our class, normally in our class. And so the question would be, well, if our entire class is going to line up at the door to go to a program, in how many different ways could that happen? And before we're done today, we'll talk about how we can make that calculation. All right? Now, what we've done on this first example, this standing in a line example, is we've just simply looked at all of the different possibilities and added them up. When there were 2 people, there were 2 arrangements. When there were 3 people, there were 6 arrangements, and so on. But we need a more economical, we need a more efficient way to do this. So we have something in math called the fundamental counting principle. And if I go too fast, remember you can always pause this screen if you want to write this into your notebook. But what it says is, if we have a variety of events occurring, so it says if event number 1, which we're going to denote as E1, can occur in A ways, event number 2 can occur in B ways, and event number 3 can occur in C ways, then when you put all of the events together, so let me circle all of these up, so when you put all of these together into one, then all of the events can occur in A times B times C ways. In other words, the product of all of the individual ways in which the events can occur. All right? And so we can then look at our, I'll just scroll the screen up slightly. We can go back to, let me switch to black so it shows up a little nicer. We can go back to our example with Abby, Ben, Chuck, and Danny. And instead of listing out all of the ways in which they could stand in a line, we could think about their positions at the door, all right? The person in the first position, third position, first position, second position, third position, and fourth position. All right, and turn the problem around a little bit and ask, while everybody is still sitting in their chair, how many different people could go stand in that first position by the door? Well, any of the four, Abby, Ben, Chuck, or Danny could, so we'd have 4 different people could be in the first position. But once one of those people is in the first position, let's say Chuck is in the first position, now how many people are left to stand in the second position? Well, Abby, Ben, or Danny, so a total of 3. But once Abby is in that second position, now how many people are left to stand in the third position? 2, Ben and Danny. And finally, once Ben is in that position, then Danny only has 1 position left. He can stand in the 4th spot. So the fundamental counting principle says is, if we have 4 different people that could stand in the first position, 3 in the second, 2 in the third, and 1 in the fourth, the total number of ways all of that can happen then is the product, so multiply those together. So 4 times 3 times 2 times 1 is 24. So 4 people could stand in 24 different arrangements at the door when we're going to one of our programs. Okay? So this idea can be used for a lot of different counting ideas. Let me give you guys another one. All right, let's go with phone numbers. Now, if you guys were sitting in your chairs like we normally would, I would ask you, I'd ask someone for one of the cellular phone number prefixes. I'm not sure what you guys have, but a popular one over the years for the Ely area is to have a 235 prefix on your cell phone number. Maybe you or someone you know has a 235 prefix on their phone number. But my question is, with 235 as a prefix for your phone number, how many different phone numbers could be created using that prefix? What follows is 4 digits, correct? So phone number might be 235 1, 2, 3, 4 as an example. Okay? Well, how many of those phone numbers could actually be created? Right? So to answer that, what we do is we just simply ask ourselves, well, how many different digits could go in this first position? How many different digits could be in this first position? Well, it could be the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there can be a total of 10 different digits that go in that position. And of course, then similarly, how many digits could be in the second position? The same, 10. In the third position and in the fourth position. So the fundamental counting principle says, if the first digit has 10 options, the second digit has 10 options, the third digit has 10 options, and the fourth digit has 10 options, then the total number of phone numbers will be the product of 10 times 10 times 10 times 10, or 10,000. So 10,000 people could have a prefix on their cell number of 235. And of course, the same would be true for any other prefix. So if we had a prefix of 320, there'd be 10 options, 10 options, 10 options, and 10 options. So here you'd have 10,000 possible phone numbers. Okay? Now that's, of course, with the understanding that there's no restriction. I'm not sure, I don't know what the legalities are or the rules are. I'm not sure if it's possible for somebody to have the phone number 235-0000. I'm not sure if they allow that number, but if there's no restrictions at all, then there would be 10,000 possible phone numbers. Okay? Here's another example. How about Minnesota license plates? Okay. Now, there's all kinds of different arrangements of numbers within the state of Minnesota, or I should say different arrangements of characters for license plates in the state of Minnesota. But I'm going to go way, way back. When I was a little McTykester, my mom and dad's license plate number was GW3232. Okay? Not sure why I remember that. Sometimes I don't remember where I parked my truck at the grocery store, but for whatever reason, I remember my mom and dad's license plate when I was a little kid. Now, in the state of Minnesota, when they used that arrangement, 2 letters, so G, W, 2 letters, followed by 1, 2, 3, 4 digits, when Minnesota was using that arrangement for license plates, how many possible license plates could be created using that arrangement, using the arrangement of letter, number, number. Okay? Well, how many different letters could be in that first position? Well, there's 26 letters in the alphabet. Therefore, there's 26 options that Minnesota had for the first character on the license plate. How many possible characters could be in the second position? Well, again, since there's 26 letters in our alphabet, we'd have 26. And then for each of the number positions in the license plate, since each of those numbers is a digit, there's 10 possible digits that we could use. And again, the fundamental counting principle says if we have 26 options for the first letter, 26 options for the second letter, 10 options for the third number, 10 options for the fourth, fifth, and sixth, it's going to be the product. So we multiply all of those folks together. And what we'd end up with then is, let me put some commas in here so you can clearly see. So the number of license plates possible at that time would have been 6,760,000 license plates. That's how many license plates we could have created in the state of Minnesota using the format letter, letter, number, 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 number. Okay? Now, anybody who would notice a license plate now would see that there's no vehicles driving around the streets of Ely with Minnesota license plates that have 2 letters followed by 4 numbers. What happened was the state of Minnesota ran out of options. They used up all of the possible license plates. So what they've done, and what they still currently use, is groups of 3 letters and 3 numbers. So now, as an example, many license plates will have letter, 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 followed by 3 numbers. Number, number, number. And with that arrangement, once Minnesota made the switch to 3 letters and 3 numbers, now how many license plates are possible? Well, there's 26 possibilities for each of the letters, and there's 10 possibilities for each of the numbers. So again, the fundamental counting principle says multiply those individual options together to get the total. So what we're going to have then is 17,576,000 possible license plates that Minnesota could create using the format 3 letters followed by 3 numbers. Okay? Another example that we can look at, and I could challenge any of you guys to give me your numbers, but let's say that you're getting dressed in the morning and you want to pick out some clothes. All right, you want to pick out some clothes. What I'd challenge you to do is think about how many different possible pants that you could throw on. And depending on whether you're a guy or a lady, of course, we'd have other options of skirts and things like that. But let's just keep it simple and just think, how many different pairs of pants could you guys throw on in the morning? Okay? How many different shirts could you throw on in the morning? And maybe let's keep it simple. How many pairs of shoes do you have available that you could throw on in the morning? Okay? Now, if you guys were actually in your desks like I wish you could be, I would actually ask for a volunteer to give me your number of pants at home. And for just our purposes, let's say that somebody has 8 pairs of pants. Okay? How many shirts might you have? Probably a few more, because we all usually have some t-shirts laying around and then some nicer shirts laying around. So let's say maybe somebody has 18 shirts at their house. And then how many pairs of shoes do you have? Well, probably a lot of variation there. Probably anywhere from 1 or 2 up through double digits. So again, let's just pick something kind of in the middle. Let's just pick some nice easy number like 10. So if you were someone that had 8 pairs of pants, 18 shirts, and 10 shoes, how many possible, I'm not sure what the more modern word, but the old-fashioned word would be, how many different outfits can you put together with those options? Well, the fundamental counting principle says if you have 8 pairs of pants, 18 shirts, and 10 shoes, then you can create 1,440 different outfits. All right, you come to school in 1,440 different arrangements of your pants, shirts, and shoes. Okay? All right, and I'd like to do one more basic counting problem. And this is a lot more fun when we can be all together. But what I'd like to do is I'd like us all to take a field trip down to the Subway sandwich shop down on the east end of town. And what I'd like to do is go into Subway and look at how many different possible sandwiches could we create, right? From all of the different options in a Subway store, how many different sandwiches could we create? Well, the key is to think about all of the different questions you're asked when you go in, all right? And I wish I had all of you guys here to help me out with these. I hope I don't miss any. But one of the first things they'll ask you when you walk in is, what type of bread would you like to have for your sandwich? Another question is, what size sandwich would you like? Another question they'll ask you is, what type of meat would you like on your sandwich? Another question, cheese. What kind of cheese would you like? About the same time, they're going to ask you whether you'd want your sandwich toasted or not. And then once it's either toasted or not, when essentially it's ready kind of for the next person, they'll usually then ask you for what type of veggies do you want on your sandwich. And then finally, they'll ask you for, do you want any sauces or dips or anything like that? And in the restaurant business, those are called condiments. Okay? So hopefully I've got all of the questions that you're normally asked when you go into a Subway store. And now what I challenge us to do is come up with the answers. So as an example, how many different options for bread do you have? Well, since you guys aren't here, I looked up a Subway on the internet and found all of the different options. But I know our Subway store doesn't have all of these. So the ones I think our store might have are wheat bread, flatbread, Italian, let's see, honey oat, Monterey cheddar, and then you can get a wrap sandwich. Now, if I'm missing any, feel free to adjust. If I didn't say one that you know that we have, feel free to adjust. Okay? But let's say that there's 6 options there. Now, how many options do we have for size? Well, with the regular bread, we have the 12-inch, the 6-inch, and if you have a little brother or sister, maybe you know they have like a 3-inch sandwich. And then I think we also, let's see, 1, 2, 3. So I think those would be the 3 sizes. We're not going to deal with any of the party subs or anything like that, so let's just keep it simple. How many different types of meat are there? Again, I looked it up on the internet. I'm not sure how many of these our Subway store has, but let me just list off a couple that I found on the internet that I think are down there. Ham, buffalo chicken, meatball, bacon, salami, chicken breast, chicken strips, chicken teriyaki, bologna, roast beef. There's a crazy pretend seafood. It's not really seafood, but they say it's like an imitation seafood. Steak, tuna, turkey, and then there's a vegetable kind of patty thing. So let me see if I got all of those. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think if I counted right, I got 16. So there'd be 16 kinds of meat. Okay? Next up, cheese. American cheddar. Let's see. Oh, there's a shredded cheese for one of the specialty sandwiches. Parmesan, pepper jack, provolone, and Swiss. So I'm not sure if I'm missing any there, but that was 7. The next question is, do you want your sandwich toasted or not? And I'm going to go with only 2 options there. I'm either going to say yes, toast it, or no, don't. I know you can say just toast it for a little while, but let's just keep it simple as yes or no. Okay? Next up, veggies. Here's again what I found on the internet. I'm not sure if our Subway has all of these, but here's what I found. Tomatoes, olives, onions, lettuce, pickles, jalapeno peppers, green peppers, cucumbers, banana peppers, and avocado. That's what I found on the internet. Again, I'm not sure if we have all of those at our store, but that's what was available on the internet. Okay? And then finally, the condiments, the sauces, and the things that you can add right at the end. Again, here's what I found. Buffalo sauce, chipotle sauce, honey mustard, sweet onion, regular mayo, a light mayo, yellow mustard, brown mustard, vinegar, oil, and I also found red wine vinegar, but I'm not sure if that's different than the usual vinegar. But if it is, there'd be a total of 11. Okay? So what we've come up with then is all of the individual choices we have as we order a sandwich. Bread, size, meat, cheese, toasted or not, veggies, condiments. And so the fundamental counting principle says to calculate the total number of possible sandwiches, we multiply all of the individual options. So here's 6 times 3 times 16 times 7 times 2 times 10 times 11. And what we'd find is that we'd have 443,520 possible sandwiches. All right, 443,520. And just to get you a feel for that, how many that actually is, if you were to eat 1 sandwich per day for a full year, so every single day of the year, you went and bought yourself a different sandwich at Subway, it would take you approximately 1,215 years to get through all of the possible sandwiches. So 1 sandwich per day, it would take you 1,215 years to get through all of the possible sandwiches. And if you said, well, the heck with it, I'm going to actually eat every single meal there, so not only every 365, but we're also going to eat 3 meals per day there, then it would take you approximately 405 years to eat 3 different sandwiches per day. Okay? So I'm not sure how healthy Subway is, but I'm not sure anyone's going to be around to be able to eat all of the possible subs. Okay? Now, one little note before we move on to something a little bit different. The actual number of possible sub sandwiches is actually much, much, much more than this number. It's actually much more. And the reason it's much more is in many of these categories, let me highlight some of them, we were making one choice in each of these categories. We were choosing one type of meat out of the 16 options. We're choosing one type of cheese out of the 7 options. One type of veggie out of the 10 options. One type of condiment out of the 11 options. In reality, of course, you can mix and match. And if you were allowed to mix and match which meats you were put together, as an example, if you were allowed to put the meatballs together with the fake seafood, that would be another possible option. Can you combine different types of cheeses, different types of veggies? Most of us probably do use more than one type of veggie. The actual numbers of sandwiches goes way, way, way up. Okay? So, I'm going to pause this lecture for now. It's already pretty long. It's almost a half hour, so I'm going to give everybody the chance to turn this one off, take a break, and then I'll finish off the rest of section 10.1 in the next video. So look for part two for section 10.1. Okay? See you soon.